So our next talk is Pam Clark, and she will talk about the Lunar IceCube.
Hi, yeah, I'd like to just give a quick update on what's going on with Lunar IceCube. First slide just basically shows the team. This is led by Morehead State University. PI is Ben Malfris, and I'm the science PI. We have a big contingent from Goddard and from BUSIC. So Goddard is basically building the Birch's instrument, which is our payload. Next slide, please. Current status. Well, like a lot of other people, we've been delayed by COVID-19 closures. So at this moment, we're still continuing integration with the spacecraft subsystems. We just successfully completed the testing in BUSIC. Propulsion system is ready for integration. Software development, a lot of the flat-sat stuff has already gone on. We await the opening of Goddard for Birches. We just allowed to go back in at the beginning of August, which means that we will complete the testing and integration probably by sometime in October, and then deliver that to Morehead with a, that basically means we have a delay of almost 6 months. They still haven't slipped the launch date, but we suspect that they will. And that's where we are. Next slide, please. Our motivation for making an instrument that required a cryo cooler, a very big challenge for a CubeSat, a 6U CubeSat, is that we wanted to cover the 3-micron band based on early results as shown in this slide. And we also believe, based on other work done with M3 data on the right-hand side, that we will potentially see water even at relatively low latitudes. So we are basically looking at water as a function of time of day. We have a repeat pattern that allows us to go back over the same swaths about once a lunar cycle, about once a month or so. Expect to see probably something like 10% of the lunar surface at 2 or more times a day. Next slide, please. Just to describe the Birch's hardware, this is a CAD model of the instrument itself with all the features of simple optics, 2 off-axis pointing mirrors, an adjustable field stop that allows us to control the size of the field of view. It doesn't have to vary as a function of altitude. We're in a regular orbit, which will vary in terms of altitude from the lunar surface from about 100 to nearly 1,000 kilometers. So that was an important feature. We have a linear variable filter, very compact way to do wavelength separation. And over on the right-hand upper corner is the ray tracing. We also have a cryo cooler and electronics. Unfortunately, we didn't get to use the very compact system on a chip because we couldn't afford it. So we're using essentially regular sized electronics. The whole thing is something on the order of just over 2U and about 3 kilograms. Next slide, please. So basically our operational strategy is
2 minutes left.
Okay, we take data about every half second or so. We have overlapping 10-kilometer fields of view as we are close in altitude. We also have the option of either changing the field of view or keeping it, making it larger so that we increase our effective signal-to-noise ratio as we go toward the pulse. So we have a nearly polar orbit, and on the right-hand side, you basically see the strategy in terms of our orbits and the overlapping swath concept. Next slide, please. Conclusions. So Lunar IceCube is the most operationally complex CubeSat to date. We provide measurements on water absorption features, including liquid water in various forms, ice on hydroxyl, as a function of time of day. We'll also cover regions that are known well on the moon, get a sense of what happens as a function of latitude, and different types of terrains on the moon. Regardless of the degree of overlap with other missions in space or time, which we're hoping for some, these missions, when combined, will provide far more systematic understanding of the water cycle. That includes Lunar Map and Lunar Flashlight. And we are doing what CubeSats are supposed to do, creating an innovative and tailored solution with a standard platform. Do we have another slide? And I'm announcing the Lunar Cubes workshop in 2021, when we will be back at work. We will be able to have a wonderful face-to-face interactive workshop, I'm hoping, associated with the CubeSat Developers Workshop every year in April in San Luis Obispo. Any questions?
Thank you so much, Pam. Does anyone have any questions for Pam? Maybe a quick one before we move on.
I do have the same question for Pamela. Are you able to map the full band of the water to deal with the ambiguity that arose from the other maps or for the feed data?
Yes, we are. We actually technically go out to 4 microns. You can clearly see the entire region around 3 microns. The only issue basically is dealing with emission, which we can model.
Thank you.
Welcome.